So, welcome everybody. I'm Alberto Ferrari. I work with Marco Russo at SQL BI. We do a lot of stuff related to analysis services. In the last, 10 years, we basically shift all our interest over the DAX language. So we mainly teach DAX, do training on DAX, do consulting on DAX. Anything related to the DAX language is our bread and butter. Today, I'm not going to talk about DAX. You're not going to learn new DAX functions or anything like that. The goal is to introduce the new composite models. Before we start talking about composite models, a gigantic word of warning is important. Composite model just hit the market in December, and it's very, very beta. So right now, anything can go wrong during this demo. Every few days, we have a new version of Power BI. They fix some bugs, they introduce further bugs. So anything can happen, don't be scared. Composite models are just starting and they will arrive over time. I have no idea when they will be generally available, but it's not be anytime soon. With that said, what are composite models? The idea of composite model is to let you extend an existing Power BI model that you host on the cloud or on your machine, right now only from the cloud, and use it using DirectQuery over analysis services. DirectQuery over analysis services is quite long as a name. We prefer composite models. With composite models, you not only connect to a database or to an analysis services model in the cloud, so you cannot just build a report, but you can extend it by adding your own tables, your own calculated column, your own measures, and make it larger. You can extend not only one model, you can connect to multiple models. You can also mix and mash up data coming from a SQL Server database, an analysis services model in the cloud, or Excel files or databases that you have on premises on your machine. It's a beautiful feature because to me is really the final feature that everybody was expecting in order to really have a corporate model that contains all the data and all the business logic of the company and let users add the tiny bits of information that are really important for them to build their own reports. We will introduce composite models. We will see several demos. I will not show you all the details, but I will try to show you also the drawbacks of composite models, because one thing that scares me a lot are people that think that they found the Holy Grail, meaning that, oh, now we have composite models and we can build whatever. We can create 10 different models on the cloud and merge them all together into a single report. That is not going to work, because composite models are powerful. They are great from a technical point of view. They are really a masterpiece, but they have limitations. So you need to know the limitation. You need to understand how they fit in your in the data culture of your company. Now that's enough for my face. Let's go straight to the demo and let's start looking at composite model when they are working. Here I have. I need to get rid of this. Okay. Here I have just a report. It's an empty report. I just open Power BI Desktop. And the first thing that I do is I connect it to a Power BI dataset in the cloud. So I just link to the Contoso star schema. No, Contoso star schema 12 million. I'm connecting with a Power BI dataset that sits in the cloud. Right now, what I have is a live connection. Live connection means that I can take from the product, for example, I put the brand. From the sales, I put the sales amount. Let me increase the font a bit, because maybe you can read, but I'm old and I have no way of reading at that size. So let's go for 20 points, much better. So what is happening is well known. I am connected to a database that sits in the cloud, and I'm running a query on top of this database, meaning that no data is being shared between my computer and the cloud. I just build the query is sent to the cloud service resolves the query and sends back the result. It works beautifully, but it comes with limitations because right now Power BI is working only as a querying tool, a reporting tool. So if I want to create a new column, for example, I can't. If you look there, I'm messing up everything as usual. Okay, if you look there, I can create a measure, but I cannot create, for example, a column. And if we go to the modeling tool, I don't have the option of creating new tables and new column. You see that both new table and new column, they are hidden. And the reason is right now, Power BI doesn't have a database. Power BI is only working as a client tool, reading information from the cloud and presenting them in a nice way. If I want to create a column or if I want to create a table, I need a place to store this information. And I don't have this place because I'm connecting using a live connection. The idea of composite model is to create a storage for this specific model that let me create new entities that use the data which is in the cloud. And to do that, there is this very well hidden button at the bottom that says make changes to this model. If you click on that, it starts with a warning that says that this PBIX right now is a live connection. If you want to make changes like renaming columns, adding new columns, or doing all this stuff, you need to translate it into a DirectQuery connection. Of course, that's exactly what we want to do. So we go for add local data model. And what is happening is that right now Power BI is retrieving information from the server and it is generating a local model that is an extension of the remote model. You see that now looks like nothing has changed, but the biggest change happens here. If I right click on a table, you see that I can create not only a new measure, but also a new column. Not only I can create a new column, but in the modeling tool, I have the option of creating new columns and new tables. And the reason is I transformed this live model into a direct query model, a composite model that composes, that mashes up data coming from the service and data coming from whatever source I want. The important thing is that I have not lost anything about the original model. The original model is still there. I can see the diagram. I can see all the information. I cannot see the content of the tables because for that I need to have the data. But I can see the structure and I can do whatever I want. For example, I can decide to rename a measure cost amount to something different and that will work just fine. But let's start by building a first column because we did that because we wanted to change the model. We start with something really, really simple. Let's create a new column in the product table. Font. Let's say that I want to categorize products. So I create based on the unit price. Or let's do that. No, let's do that on the unit price. It's easier. I want to create a product category and I just write DAX code. If the product, I don't have the list price. Cool. So we need the list price. Let's do that. We create a new column. Average price, which is calculate average sales that's weird. Average sales net price. IntelliSense is not working as I would like. And then all except product key. What is this code doing? Well, I totally forgot that I don't have the unit price in my table, so I create a column in the product table that computes the average net price from the sales table for all the products with the same key, that is the current product only. Now I have a new column. And I can create another column based on the average price. That is the product category. That says if product average price is less or equal than 100, then it's low. Otherwise, if it's less than 1,000, it's medium. I'm just creating numbers right now. I have no idea whether this will create a good classification or not. Otherwise, it's high. So I first compute the average price, so the average price of my product, and then I categorize it with 100,000 or between 100,000 or whatever other price. And I made some mistake. Yes, I need an if here. Much better. Okay, so I created two columns actually, and I can use the column right now. I can get rid of the brand, take my product category, drop it in the report, and it's going to take some time to compute the value, but at the end it produces the result. Let me transform that into a matrix and also format the sales amount as a decimal number. So this is the amount of sales of products which are categorized high, low, or medium. And I did that by extending the model. That is extremely important. You see that I didn't have to load the data from the model. Actually, this model right now is extremely small because I have not created any, I have not loaded any data. I have not stored information anywhere. I'm just connected to a model and I am extending it with new entities. I can create measures, but that I could already create using a live connection. Now I can also create columns in the tables that are stored there. All the measures that were available in the model are there, all the tables are there, all the relationships are still there, and I have the power of creating these calculated columns. Now, before we move further, an important detail is what is the extent of this calculated column? What can I do with these calculated columns? I cannot do whatever I want. There are limitations. And to be very honest, the limitations are still not completely known. We are experimenting, we are working with them, we are finding what we can and what we cannot do. But the important detail that you need to think about when you work with or when you analyze composite models is that the code that we write right now is not executed by my local machine. It is true that the composite model has a local storage, but if the query can be pushed to the server, then the query will be sent to the server. Think about that. The model to which I'm connected contains 12 million rows in the sales table. I do not expect to download the 12 million rows to execute the query on my local machine. I strongly prefer to push the calculation to the remote server. That means the code that I write in calculated column needs to be pushed to the server. Otherwise, the performance would be absolutely horrible. It is not a very big limitation, but it is a limitation that you need to take into account. So you cannot create any kind of calculated column. You need to be prepared to live with this first limitation. What you can do is build any kind of measures. But again, keep in mind, if you create a measure and the measure mashes up data that is local and remote, the engine will need to move data back and forth between the local server and the local machine and the remote server. So this is going to be heavy and not, of course, extremely fast. So we have seen that we can create a calculated table. Can we load further data? And actually we can. Now that we have a model here, I can get data from. Yes.
Sorry, I disturbed you. There are a couple of questions that I think are relevant here. So I'm not 100% sure. So there was one of them was where to click to extend the model. So there was someone who asked, if you could show that.
Well, you no longer see that now, but here at the bottom right of the window, there is this storage mode that right now says direct query. When you start, so when you start for the first time to build a model connected to the service, you will see that it says storage mode live, and there is a small blue text that says make changes to the model. One thing that is important, and I forgot to mention that, that if you want to use composite model, you need to enable that. Right now it's in preview, so you need to go in File, Option, Preview Features, and among the many features, we have DirectQuery for Power BI dataset and analysis services, which is the long version of composite models. You need to have that enabled, otherwise you don't have the feature available. There are a lot of other features in preview, but to me, this is the coolest one.
Okay, thank you. The other question was, can you do that in a variable, but there's no context, so I will ask the person to ask again later on. So thank you.
Okay. But I guess the question was if I could compute the average price in a variable, and yes, the answer would be yes. There would be no problem. Also, performance-wise, it would be totally the same. And where was yeah. The idea was, can I load data in this model? Because now I have the remote model and I also have a local model. Can I fill it with some data? And actually, I can do that. I can go to Excel, connect, for example, to a budget table. The budget table is a table that contains some budget information, totally useless, but I use it just to connect tables, connect data. So I can take the budget. Let me see the content. The budget table, this is an Excel file. It contains country, region, brand, and then low, medium, and high, which are the 3 possible scenarios for the budget, and a bunch of other columns that we are going to remove. I can click on transform data. Again, it's worth to repeat that the actual data is still in the cloud, but I'm loading data on this machine. So we want to keep country, region, brand, and low. So let me remove a medium. So let me remove all the remaining stuff. And again, that is important. I have the full power of Power Query. I'm not restricted. I can load the data in an easy way. This is a budget table. Click on Close and Apply. And another warning, again, this is important to understand. I know everybody, whenever you see a warning and you just click on OK, because we receive just so many warnings that we stop caring about them. But there's a potential security risk that you need to be aware of. As soon as you mash up data between the local machine and the remote server, that means the data will be passed back and forth between the two machines. So actual data from the Excel file will be sent to the remote machine, and data from the remote machine will be sent back to my computer. So this movement of data you need to be aware of, and if you trust everything, you can just go ahead. That's exactly what we're doing. I'm using only demo data, so I don't care at all about security. And now I have my budget table here. Look what happened. Here I have also the button from where I can look at the tables. And if I click on that, I can see the budget table. I still cannot see sales. I cannot see customers. I cannot see any of the tables which are remote, but the budget table, because it's a local table, I can see the content. It has country, region, brand, and the value. Here I want to rename that. Let's call it the budget amount. And I can start mashing up data. So I have the product category. I don't want the product category. I was slicing by product brand, as I have the brand, the sales amount, and I want to see the budget for this given brand. So I can take from my budget table the budget amount, drop it here, and it's not really cool. You see that the brand is not actually slicing the budget amount. The reason is pretty clear. I have loaded the table, but I didn't build any relationship. Come on. OK. You see that my budget table is here, and it is completely disconnected from the remaining part of the model. It would be great if I had the option of creating a relationship between product and the budget. And actually, I can. That's one of the beautiful things about composite models. I can take the brand, connect it with this brand, and now product can be linked to budget. Because the brand is neither a key in product nor in my budget table, the relationship will be a many-to-many relationship. We don't want bidirectional, we want product to filter budget. But I can just click on OK, and I have created a relationship between a table that is still in the cloud and a table that is local to the model. But the two are now linked through a relationship, meaning that when I make a selection on the product table, the filter will reach my budget table. And we can actually look at that. You see that now the budget amount is sliced by the brand. Numbers are not meaningful at all here, but the thing is not the number. The important detail here is the fact that you can create this relationship. We have the budget in the customer. We have also the country region, so we can also build a relationship with country region. If only I find it. Country region with country region. It's again a many-to-many relationship. Many-to-many, where customers filters budget. And now I have two relationships between product, customers, budget. I can get rid of the brand and slice, for example, by country region in customer. And it just works. I have different country region, the amount of the budget, different values. Again, it's not important, the value. The important detail here is the fact that you can create this kind of relationship. And you can just imagine the kind of power that we are giving to users. You have the corporate model containing all the sales. You want to categorize customers in some way. You can do that. You can build your table, load it in the model, and build your own private data model that can benefit from the content of the data in the cloud. An important detail about that is that you can also refresh the data. Let's see another example. Let's say that I'm interested in clustering my customers. I want to understand whether my customer, I want to divide class customers based on the sales amount. This operation before had to be done either asking IT to change the model in the cloud or by loading all the data about sales and then doing the clustering in your own data model. Now what we can do is connect to the model in the cloud, add a table that contains the different clusters of my customers, and then author a piece of code that solves the problem. When writing this piece of code, you need to pay attention to a lot of small details, but we will see that one step at a time. Let me start with Excel. I have a table, sales cluster. We will look at that inside Power BI. That contains just 3 rows, which are low, 4 rows actually, low, medium, high, and very high. So any customer that is in between 0 and 2000 is considered low, between 2000 and 5000 is medium, and so on. And this is the amount of sales. We can transform the data just to check that it's correct. Yeah, we have this row that we don't want. So let me get everything that is not null. And it's called sales clusters. That is fine. Okay, in the meantime, let me just jump and take. Okay. I had to take the code because I don't want to write the entire piece of code, otherwise we spend too much time. Now I have my sales cluster table. We can look at the content. The sales cluster contains the cluster, the minimum value, the maximum value. And the next step is that I need to build a measure that matches up this data. Let's pretend that I want to understand that for every cluster, how many customers fall in between that cluster. So how many customers have an amount of sales that is between 0 and 2000. And I want to make that dynamic. I'm not interested in computing as I did for the product the total sales amount for each customer and then build a static calculation, because I want to be able to filter by brand, by color, by year, by whatever, and the measure needs to be dynamic. So I can actually write the measure, which I'm not going to do because it would take too much time to build the entire measure. Or actually, we can do that, so we also discuss the performance. Let's build a new measure. I want to compute the customers in a cluster. I have a lot of different ways of computing this measure, the fast and the slow. I'll go straight for the fast, because if I write the slow version, that will take forever. I actually recorded a video where I show the slow version of the code. And if you are interested in performance with composite models, just jump to YouTube and take a look at that video. It's one of the last unplugged that I recorded, because it's very educational. For now, we just build the measure by ourselves. So if I want to cluster my customers, I need to first create a table that contains for each customer its sales amount, and then needs to be dynamic. And a variable is the perfect place where to do that. So we create a variable customers and sales, where I just use add columns to all sales customer key, a new column that I call amount that contains the sales amount. Then I will put the cluster in a report, so I need to find the two boundaries of the cluster. So I create min sales, which is just the minimum of sales cluster. In sales, I need the max sales, which is the max of sales clusters. Sales cluster max sales. And then I need to find how many customers fall in between. So customers in segment filter. Customer where no, I was making a huge mistake, and we'll discuss that in a second. I want to filter my variable customers and sales, retrieving all the values where the amount is greater than min sales and where the amount is less or equal max sales. And then return count rows of customers in segment. Now, this code is going to work. Before discussing it further, let me confirm it. I talked too early. I'm totally not sure that this code is actually going to work. I just hope that it will. Okay, if I slice by cluster the sales amount, you see that this is not slicing sales amount, because again, my sales cluster is totally unrelated from the model. But if I use my measure customers in cluster and I drop it here, you see that it shows 116 customers in the high cluster, 18,000 clusters in the very high. So it looks like my segmentation table is completely wrong, because either a customer is high or very high, and I have nobody in the low, medium, and the lower cluster. Let me get rid of sales amount. Maybe we can filter by year to reduce the amount of sales. So we put the year on the columns. Let me try that again, the year. Oh, it doesn't work. That's kind of weird. If I remove that, cluster on the rows. Okay, calendar year on the columns. Now it works. Now it works a bit better. So you see that my segmentation works a bit better. It shows 2,000 customers are high in 2007, low, medium, very high. I have the full power of Power BI available. So my sales cluster table, I can sort the cluster by minimum sales. Let's sort it by minimum sales. So it will show low, high, very high, and medium. Okay, low, medium, high, and very high. The important detail that is worth noting is that this calculation, customers in cluster, right now, as you have seen, is quite fast. Keep in mind that the model in the cloud has 12 million rows. There are around 18,000 customers, so it's not large, but it's not even trivial. It's a reasonable model, the kind of model that everybody works with every day. The reason is this fast is because I wrote this code paying a lot of attention to avoid moving data back and forth between the server and the local machine. Look at what I did. I created this variable that for each value of the sales customer key computes the sales amount. This entire calculation happens on the remote machine. There is no need to use the local model to perform this step of the calculation. Then I retrieve the minimum sales cluster minimum sales, which is coming from the local machine. So this step can be executed on the local machine only. The same for this step. And this is the only point where the two engines actually mix, because I filter the content of this variable and I retrieve only the number of customers that are in between the two boundaries. But because I save this in a variable, what I expect the engine to do is to compute this table on the server, transfer the data of the variable from the server to the local machine, and then execute the code on the local machine. This table has the size of, has one row for each customer, so it contains 18,000 rows. And moving 18,000 rows over the internet, it's not a big deal. You can do that expecting a good performance if you have a good internet connection, because otherwise this table is not trivial. It's kind of large and performance might start to suffer. If instead of using all sales customer key here, I would have used customer, I'm not going to confirm this measure, because if I do that, I will have to wait like 30-40 seconds for the code to run. And the reason is I would have referenced customer instead of all sales customer key. Now, this table contains the entire customer table, so I'm asking to DAX to take the entire customer table from the server, move it to the client, because I need it to do further processing, which I actually don't need. The thing is, if I do not pay attention to how I write the DAX code, it is very easy to put the composite models to their knees. They will not be able to compute their values, or it will just take forever to compute the value, just because the DAX code is written the wrong way. Imagine, for example, if you write an expression that requires the entire sales table to be moved back and forth. That is 12 million rows. It will take probably several minutes to move the data from the server to the client, and it's likely part of that data will need to go back to the server. So you need to pay attention to how you write the DAX code. And that's something that I continuously repeat. If you plan to use composite models, spend time not only learning DAX, spend time learning how to read a DAX query plan, how to understand how the query plan works, and how to actually understand what the engine is doing. Because with Vertipack models, with regular in-memory models, you could make a lot of errors and you would never notice. The worst code you can write is still quite efficient if you're working in memory. With composite model acts as a multiplier. So a small error becomes a regular error, and a bad error becomes a gigantic error. It's really easy to make mistakes. Now, I'm not here to sell you anything, but trust me, if you plan to use composite models, spend time learning how to optimize the DAX code, because without this knowledge, you are going to have problems much earlier than you expect, and you will complain that composite models do not work. That would not be correct. It's the fact that the DAX code you wrote is driving composite model to do the wrong stuff. Learn to author code and make it work. And I'm not here to blame you. Keep in mind that to me, finding the way to author this simple measure was a couple of days of work, because I wrote code like this tons of time during my demos and my trainings. But when I realized how composite model work, I needed to rethink the algorithm, taking into account where the data is and trying to minimize not the scans of vertipack, but instead the transfer of data back and forth. The same is true for relationships. I'll show you how easy it is to build those relationships. But again, when you look at a relationship like this one between product and budget, you need to pay attention to the price of a relationship. The price of a relationship in a composite model depends on the number of the cardinality, the size of this relationship, which in this case is the number of brands. Because we have probably 10, 12 brands, this relationship is going to be super fast. But if we build the relationship at the product level, that is already a few thousand rows. If we build the relationship at the customer level, that will be a relationship with 18,000 rows. So moving the relationship back and forth is going to be expensive. If you have a large table with a few millions of rows and you build a relationship between that table and a local table, this is not going to work. You will have to wait forever to build the report. And that's bad, because you will, again, not be able to use a powerful feature just because you didn't understand the small details. In a similar way, a feature that a lot of people were waiting for, and I personally don't think is already here, meaning that it is here, but it's going to be probably slow, is the ability to mash up data from different data sources. So the question is, I connected to one Power BI model. Can I connect to another one? The answer is yes. You can still click to Power BI dataset, go to anything like I can connect to another Contoso star schema, click on create. And at that point, I will have two DirectQuery connection over analysis services plus my Excel file. Technically, it works just fine. But from a practical point of view, having two models is totally useless unless you start building relationships between those models. And this is even harder because now the two models are in the cloud. The local machine is here on-prem. And what happens is that if you build a relationship between tables in the two models, data need to be taken from one model, downloaded on the local machine, sent on the remote on the other island, processed there, the result need to come back, and the local machine need to mash up everything. Depending on the size of the relationship, this can be super fast, so you have a beautiful experience, or extremely slow. Not only you don't have limitation in connecting to multiple DirectQuery analysis services, actually you can connect to whatever. You can create a connection with SQL Server. So you have the option of connecting an analysis services model in the cloud with a SQL Server database, which is somewhere else, either on this machine or anywhere else. And everything works just fine, but you need to know what you are doing. One thing that I forgot to mention is the data refresh. Let's go back to our report. Now you see that we have the clusters, low, medium, high, very high, and everything looks to be very high, at least in 2007. Then in 2009, the numbers are different. That might lead us to think that the clusters we built, well, they are not correct. We didn't build a correct set of clusters because customers are not sliced in a nice way. And if I want to check that, I can do that. I can just go to the folder where I have my sales cluster, open the file in Excel. Here it is. and change the content. Let's say that we want to go here to 50,000 and this goes to 20,000. Okay, it changed the boundaries. I just save the file, close that, and in my model, all what I need to do is click on refresh. What is refresh doing? Refresh is not, oh, it's doing something. It's not refreshing the data from the cloud, actually. It is refreshing the data which is in my machine. And if I did it correctly, now you see the numbers changed. Everything in 2007 was very high. Now a lot of customers moved to high because I changed the boundaries. And you can imagine the power of this. You can create your own configuration table, change them on the fly without having to worry about the cloud service being refreshed. That is in charge of IT. They do whatever they want. They refresh it every day, every night, every hour. That depends on them. You have your own model and you build your calculation. Speaking about limitation, I told you at the beginning, you have limitations. So you cannot create any calculated column, any measure, any computation. To be honest, you can create most of them. It's very hard to find calculations that do not work the expected way. But sometimes you might end up building a calculation that cannot be pushed back to only one machine, so the mashup engine is not able to perform the calculation, and then it throws an error. Let me show you an example. Let's say that, and that's just for educational purposes. It's an example that serves no purpose. Let's say that I learn how to create a new column, how to load data, and I can also create a table. So I can create a table that contains customers with sales, where I do add columns to all no blank row of customer key, and I create a column customer sales, which is just sales amount. That should work. This is a calculated table created on this local machine. Because it's a calculated table, I should be able to see that customers with sales, I have the customer key and the customer sales. Now, can I create a calculated column in customer that references this value? We can give that a try. Because now I have my customer with sales table. I have the customer table here, and I can build a relationship between customer sales and customer based on the customer key. Where are you, customer key? Customers with sales, I want you to be on the many side, many to one with customer and single relationship. So customer filters customer with sales. As I told you, this is for educational purposes only. It doesn't make any sense to create this calculation. But the question is, can I create a calculated column in customer that references customers with sales? The answer is no, I can't. If I go to customer and I create a new column, live test that does calculate sum of customers with sales, customer sales. I hope the syntax is right because IntelliSense is not helping here. All except the customer key. Let's see what happens. Yeah, at least the error is the correct one. You see, it says the column customer test cannot be pushed to the remote data source and cannot be used in this scenario. This calculated column should mix data from the cloud and data from the service in a way that is not yet supported by the engine. We don't know if this is going to go away with GA or if this error is here to stay. So if it is expected that you will not be able to do all kind of manipulation of data. What I think is that this error is here to stay. So there will be scenarios where you will not be able to create calculated columns or calculated tables if they mash up data from different tables. Imagine, for example, you want to create a calculated column that stores information from the product table, which is in the cloud, and the SQL Server database that is somewhere else. That will be a nightmare to compute, probably too slow, and so they decided to cut it. That does not mean you cannot create the same calculation with a measure. With a measure, you have much less constraint, but you have problems in performance. So if you mash up data coming from different data sources and you do not pay attention to the amount of data that moves back and forth, it's very easy to create measures that run extremely slow. So we have seen the difference between, basically, we have seen what composite models are. We have seen what you can do, create calculated columns, create calculated tables, extend the model. I haven't shown you that you can rename columns, but you have the full power of Power BI available. So there are no real limitation in the kind of operations that you can do. I think it's time to spend a few seconds talking about the scenarios where it makes sense to use these composite models. Does it make sense to use composite model all the time for every calculation? The answer is no. It makes sense to use composite model once you structure the data culture in your company, saying that you have either an analysis services or a Power BI model that is stored in the cloud that contain most of the business logic and most of the data that is useful for everybody, but it does not contain specific calculations, specific measures, specific aggregations that might be useful for a few people. Then those guys, they will be able to connect to the corporate data model, extend it with some calculation, and produce their own report. In turn, and that is important to note, their result, so a composite model, can be pushed to the cloud, and then you can further connect to that model. So you can build multiple hoops, multiple jumps. Right now, there is a limit, which from what I read is 3. So you cannot make more than 3 jumps before you reach an actual analysis services model containing the real data. But that is an artificial limitation. It's not a technical limitation. Technically, you could make as many jumps as you want, even though, as you can expect, every jump comes with a price. So you should not make too many steps before reaching the actual data. Otherwise, the model will become slow for no specific reason. So the scenario where you create a small you integrate a small set of data into a corporate model is a scenario where, in my opinion, it makes a lot of sense. I heard a lot of people that are thinking about using composite model to merge different data models that are already in the cloud. I honestly don't know if this is going to work or not. I made some tests. Sometimes it's very fast, sometimes it's very slow, and the problem is always the cardinality. The problem is that if you have multiple models and you want to link them through some dimensions, the cardinality of this dimension is not going to be small. Just think about the data. If I have 2 models and I want to link them, I need at least to build the relationship with the data. Let me show you that, because even though it's not so fascinating, because again, it's just for educational purposes, it gives a meaning to what I'm saying. I have this model. Let's pretend that I connect to another Power BI dataset, which is the same we are using here. It's still Contoso, but just a different version of Contoso. Because this model is already a composite model, it doesn't create a live connection. It goes straight to another DirectQuery connection. Now I have the set of tables here, which is the meshing up of the original remote server and the local remote server. And I have a bunch of tables here, which happen to be the same that I have on the other side, which is another composite model. The 2 are still disconnected, so there's no possibility of creating a report that matches up data from tables in the 2. I will need to build a relationship, but building a relationship means that I need to find tables that have a similar meaning and create the relationship. Let's talk talk about the date, for example, I will want to see data from the sales or measures from the two filtering date. So I have date, I have date two, and I need to build a relationship so that if I filter this table, the filter will go there. What is the best option to do that? Should I create an intermediate table in the middle that filters both? That might be. Or should I create a relationship between date and date as a one-to-one relationship? Again, that might be. This is what the engine should suggest. I want to build a one-to-one bidirectional relationship. And it looks like I crashed Power BI. Yes, but luckily this happened exactly when I was at the end. No, it's actually working. It just took a lot. I can create a one-to-one bidirectional relationship. Click on OK. And now if I filter data from this table, the filter will go to date and then move again there. But the size of this relationship is the number of days. You have seen that it took a while. I was thinking that Power BI was crashed. Actually, it was just thinking. It was probably checking that actually all the values of date in one table match the values in the other side in the other table. This takes a while. So a model built using this technique, do not expect it to be fast. You can build one if you really need, but I wouldn't go for architecturing my company based on this because it's just too early. Despite being powerful, it's not as good as a real model. So we still live in a world where we have one large corporate data model and many customer model, many local self-service model built on top of it. But now, instead of only creating measures like we did in the live connection, or needing to import the full set of data, then you can actually extend the existing model, adding more features, adding more tables, and make it more powerful. To me, this is a giant step ahead in the adoption of self-service BI, of the good self-service BI. And it's probably the first time that I really start thinking that Power DirectQuery is not so bad. I have never been a big fan of DirectQuery, which is the polite way of saying that I always told to all of my customers to stay away as much as they could from DirectQuery, because DirectQuery over SQL is not only kind of slow, but to me it's not really useful at all. Unless you have a gigantic data model, and if that is the case, we can work on reducing it. It's always good. Or DirectQuery doesn't make any sense. It's typically better to load data in memory because performance is so much better. And the benefit you have from DirectQuery over SQL is really limited. DirectQuery over SQL means linking to data. Not so useful. It's better to load the data. DirectQuery over analysis services, that is different. You're not linking to data. You're linking to a semantic model. You're linking to a model that contains business logic, measures, tables, relationships. It's a real corporate semantic model. You are linking to it and you are extending it. That is a totally different story. To me, DirectQuery over analysis services, that is the new composite model, is a real breakthrough. And I strongly suggest to everybody, start thinking about using it as soon as you can. Start learning it, but do not use it. Wait before using it until you are proficient with DAX. You understood exactly all the implication of using composite models. To me, I started using with composite models a couple of months ago. I spent some time every day playing, doing tests and experiments, and I still don't have the feeling that I know enough about composite model to suggest a good architecture. I've seen somebody else on the web already pushing for best practices over composite model. To me, I think it's just too early. We don't have experience. So start learning it, but don't rush to implement it. Take your time and go a bit slower because it's an extremely powerful weapon. And we typically do not give weapons unless people are trained to use them because they are dangerous. And the same with composite model. If earlier you train and then you start using them. Okay, I think I ate up all my time, so I'm not gonna talk anymore. Maybe there are other questions, otherwise I can leave my space to the next speaker. Now I'm searching for Teams.
Yeah, Alberto, there are a few questions.
Here you are.
Yeah.
Okay.
So sorry, there are a few questions. So I would like to. They are a little different, you know, directions. So I will just take them from the top, and we will see how it goes. So first one is from Sandeep. He's asking if row-level security will work over composite models.
It will, of course. When you connect to a composite model, you are basically connecting to an analysis services model. So row-level security is still applied, and whatever query is being executed, it will be subject to row-level security. Composite model are a direct query, but instead of executing a SQL code, it executed tax code. But still, there is a clear separation between the server and the client. It is still subject to row-level security. Otherwise, that would be really a security nightmare.
So even if you have one, one Power BI model that has row-level security, and then you import some other data, the original row-level security will be respected, right?
On the analysis on the remote server, on your local server, it's up to you to set up.
Yeah, of course. I mean, in when you publish it, right? Yeah. Okay. Fantastic. So the next question. So a very specific couple of questions about the clusters you were creating. So they're not really related to the subject you were talking about, but
no problem.
In practice, how do you set a range of values for clusters? Do you typically use a model like k-nearest neighbor algorithm, or just use an interaction with a subject matter expert?
Well, first of all, let me tell you, I understood half of what you said. Probably I'm ignorant about how to define the clusters. What I do is I just type in random numbers and see what happens. Yeah. Which means that if I were to do that in the real world, I would probably talk with an expert trying to understand what numbers make sense. One thing that people don't realize about myself is that I'm totally ignorant about statistics. I know the basics of statistics, but I'm definitely not a data scientist at all.
Yeah, I'm with you there. That's the same. I can
you cannot know
calculations, but I cannot design them. So the next question is: can you use a local analysis services model, or is it only possible on Azure analysis services?
Well, there are multiple answers to that. Right now, it does not work with SQL Server 2019. So it requires the latest version of analysis services that right now works only on Power BI and on Azure Analysis Services. So on-prem, it is not expected to work. Mainly because it uses functionalities like functions and features that are not available in SQL 2019. What is going to happen with SQL 2020, 2021, or whatever will be the next version of on-prem? I honestly don't know. I don't know. So I don't know when there will be the next version of analysis services, and I don't know if they plan to support that query of analysis services with the on-prem version. There seems to be no reason not to support it because it's only a matter of features available. But marketing and sales and this stuff anything can happen. So as of today, it does not work. Tomorrow we don't know.
Yeah, that's the future. Who knows what happens in the future? Yeah. So the next question: any advice when connecting Power BI Premium shared dataset with a table from Synapse Analytics?
I didn't understand. Can you just repeat the question or rephrase it?
Any advice when you're connecting Power BI datasets with a table from Synapse Analytics?
I don't know what kind of advice we could give. I mean,
I think we should recommend that person to come to our next meeting where Synapse Analytics is the
Okay.
is the topic, and the person doing the Synapse Analytics talk actually knows very Power BI well as well. So.
That sounds like a very good advice.
So the next question from Sandeep again is your recommendation to be very careful when importing multiple data sets into a single report?
Yes, totally. The thing is, in general, what I say is be very careful when you use composite models. They are extremely powerful. They are extremely useful. They are extremely dangerous. I mean, I went on saying the same stuff with the bidirectional cross filter. I told everybody from the very beginning to stay away from bidirectional cross filter unless they knew what they were doing. But the thing is, bidirectional cross filter was not so useful. So what's the point? I could tell everybody stay away from BiDi and just work with a regular relationship. Life was easy. Composite models are not useless. They are extremely powerful. Everybody wants to use them. So I cannot tell people to stay away from composite models. I would never do that because they are so cool. So I need to give the other advice. Start learning, because if you are not skilled enough, you might end up in trouble. So go ahead, learn how to use them and then use them because they are so powerful.
Mm. And I think the next question is actually a great extension to that. The question is, I noticed there are a lot of optimization knowledge is needed by the analyst. Yep. Is there any work being done to have a query optimizer that will reduce the load on the human analyst?
Well, the easy answer to this is no. Meaning that I'm not aware of any improvement in the optimization techniques or in the optimization tools or even in the development tools in Power BI and analysis services. Optimizing DAX is hard. Optimizing a data model is hard. It's still a very complex technique. You need to know a lot of details, and the tools are basically DAX Studio. So that's the only tool you have available to optimize DAX code. DAX Studio is powerful, but you need knowledge to do that. And I don't foresee anything better happening in the next few months, probably years. So if you plan to learn how to optimize DAX, I'm sorry, you really need to roll up your sleeves and learn the details, because I mean, Power BI is super easy if you want to do basic stuff. It becomes kind of complex when you start to write simple DAX code. It becomes very complex when your DAX code is rather complex. And it's really, really hard when it comes to optimizing. So you need to follow all the steps, reach the climb of the hill, and at that point, you will be able to do whatever. And because there is a lot of road to take, my suggestion is start now. So start early, because you will benefit from that. Learning how to optimize DAX is extremely useful.
Okay. Great advice, thank you. The next question is from Declan. Can I publish my local composite model to Power BI for access by my colleagues? And what happens with refreshing data? I presume I need to put my local file onto Azure storage?
Yes, exactly. Meaning that you can publish your local model, your local composite model to the cloud, and that will work just fine. In order to refresh, either you set up a gateway so that the service has access to your machine and is able to do the refresh, even though nowadays everybody's pushing data in the cloud. So probably the easiest thing to do is to store your Excel files in the cloud. It's enough to put them on OneDrive, so nothing hard. That way, the service will be able to connect to the cloud file, do the refresh, and everything will work just fine.
Okay, the next one is very interesting. It's from Andreas. If I merge two datasets from the same workspace and then also publish the new dataset to the same workspace, is there really a big performance impact? There must be the functionality that will decide that.
Actually, No, actually, the answer is yes, because there are still different databases. I just tested it on simply on my machine. So I just connected to a Power BI dataset hosted on my local machine, and I created a composite model again on my machine, because at the beginning my idea was that the network, so being connected through the internet, was causing slowness and problems. This is not true. The internet is used very efficiently. So if you do a local connection, is nearly the same speed as a connection with the web. The problem is the size of the DAX queries that need to be sent back and forth. They are still different servers. It doesn't matter, different databases. It doesn't matter if they are on the same instance. If you just think about a query, a DAX query that contains the full customer table embedded as text, because it needs to be sent to the other side. So you need to prepare the query, write down the query, send to the other machine that need to parse that content that contains the full customer table, and then answer. It's gonna take forever. I mean, the guys at Analysis Services, they are totally geniuses. It's talking with them is depressing because you feel so idiot talking with them. They are really smart guys. So they might come up with some beautiful solution in the future that I don't know. Today, what they did is already unbelievable. So I honestly find amazing just that it works. I started dreaming about composite models 10 years ago, and seeing them implemented is amazing. They will get better. I'm not here to say that it's wrong or they are badly implemented. They're a beautiful feature that requires some knowledge and that will become better in the future. Today, it has limitations.
Okay, so we have another question from Sandeep here, is that when you are, because you're converting from live to DirectQuery, does that mean that time intelligence, functions in DAX won't work?
No, because the limitation over time intelligence is in DirectQuery versus SQL. It's not in DirectQuery against analysis services. There are a lot of limitations in DirectQuery over SQL. If you think about the columns that I created, a calculated column that contains a calculator cannot be created in DirectQuery over SQL because that would be too complex. DirectQuery over SQL comes with a lot of limitations which are completely gone with DirectQuery over analysis services, because on the other side, on the remote server, we have analysis services, not SQL. So the two can talk much better than what happens between analysis services and the SQL server.
Okay, thank you. So I think this is the last question. Do you see that self-service BI might be difficult with this type of composite model, since the users will need to know how to correctly create the calculations as to avoid making the DAX error in regards to performance? So basically, that's self-service.
Yeah, I mean, this is the last question, and it's actually the one that I could talk for hours. So kind of a problem. No. I'll try to keep it very short. What I believe is that self-service BI has always been difficult. So don't think that, don't just trust what marketing people say. They sell you Power BI saying that self-service BI is the future, 5 minutes to wow, and you will be able to do all of your calculation with a couple of clicks. I'm guilty of that. I shown you calculation tonight, and I typically show calculation in my sessions where I try to explain the details, but a lot of times I show how powerful DAX is, but it doesn't mean it's easy. Learning DAX is complex. Learning data modeling is hard. Learning optimization techniques is hard. In a word, doing business intelligence is hard. That's the reason why we don't have so many business intelligence consultants, and being a BI consultant is a very desired skill. So it has self-service BI is not easy at all. The tools make it look easy, but actually it's very complex. Doing self-service BI is really a complex topic. With that said, learning it is fascinating, it's cool, it's powerful, and I strongly suggest everybody to start learning. What I want people to be aware is that it is not easy as they want to sell. If you plan to be serious with self-service BI, plan a study path. Do not just copy code from the web and hope it works, because it will not. Or maybe it will give you the impression that it works, even though it doesn't, and produces wrong numbers and you don't know how to debug them. So becoming a BI professional is, to me, is a beautiful path. It's exactly what I did. That's why I suggest everybody to do that. But plan to take time to study. And I'm not selling just my courses. You need to learn data modeling. You need to learn DAX. You need to learn new techniques. You need to learn a lot of important details. It's a beautiful path, but it takes time. So composite models are just the last point in this long path.
I used to sometimes say that, there's no true self-service. There's always, you cannot have only self-service. There's always need to be some kind of specialist help in there.
Yeah, or the self-service guy.
That's why we have a
user
job.
Becomes a specialist, which is cool.
Yeah, of course. That was the last question. So thank you very much, Alberto. It was a fantastic session. I actually learned a lot. I think it was really nice to get this introduction. I have not had time to actually feel and try out this feature, so I was really happy to see this. And thank you for taking the time out on this great Tuesday night to present for us.
Thank you a lot
for
hosting me, and till next time, enjoy DAX.